Hi, so today we're going to be talking about the 8.4 in our book, which is the normal distribution. This is where we talk more, we're expanding more about the describing and analyzing data, especially with bell charts. A key thing that you'll be seeing a lot is the term z-score. And the formula, for a quick version, the formula of finding a z-score is z is equal to our data value minus our mean divided by our standard deviation. Now there's a few ways that Hawks and other people will write this, and it's z is equal to x minus x with a line over it over s, or z equals x minus this Greek symbol, I think it's mu, divided by, I don't even remember what this one is, delta. Anyway, standard deviation. It all means the same thing. Whoops. All means the same thing. I don't know if they'll be using it interchangeably or not, but it all means the same thing. Yeah, you don't need to worry too much about it. So then, that's really the biggest key thing. And for a more in-depth explanation for why this is the way it is, well, actually, I'll save that for near the end. You'll have questions where it's asking you, so it gives you your curve, it gives you a z-score, and it will ask you what percentage lies in like a certain quadrant, like certain area of that line, of that graph. And we'll be using Excel spreadsheets again. And the two main things are norm.s.dist and norm.s.inv. When you plug these into Excel and you want an equal sign before any calculations that you do, that's how it tells that you are not just putting text in. That's how it knows you're doing a formula. So with norm.s.distribution, this is the function where you plug in a z-score and it gives you a percentage. And norm.s.inv is when you plug in a percentage and it gives you a z-score. Now norm.s.distribution and norm.s.inv, both of these take your spot that you're at and calculates to the left. At least I think it does for norm.s.dist. I don't know if it's applicable for this. But so if it says something like greater than your z-score, you're going to have to minus this by 1 or 100. It returns back a decimal. And when you, just as a note, when you are plugging in norm.s.inv in your parentheses, you don't want to put it in percent form. I don't remember if it works, but just to stay on the safe side, do it in decimal form. So if you were doing 30%, turn it into a decimal. Norm.s.distribution on Google Spreadsheets, this doesn't matter, but on Excel, when you have norm.s.distribution, it gives you a parentheses, you put in your z-score, and then it asks you for true or false. We don't cover what these two mean in our class. Just know that it's always going to be true in our class. So that covers it. Before we hop into examples, I'll give more of an example for what the z-score is in really simple terms. So let's say you're on a sidewalk and you're just a little dude on a sidewalk, and you can take each step that you take is 12 inches. And let's say these sidewalks are labeled with what feet they're at. So let's say we're at 36, the 36 marker. This would be the 24th marker. This would be the 12th marker, and this would be 0. And this would be the 48. This would be the 60. This would be the 72. And let's say you see a ladybug right here. And he's just chilling. You know for a fact that this ladybug is at the 4 inches marker. We want to find how many steps it would take to get to that ladybug. We know that each step, one step, is equal to 12 inches. So if we take one step here, that's 2 steps, but 2 steps is less than here, and 3 steps is too far. We want to find right here. So if this is at 4 inches, and the next will be 12, that leads us to believe that there is 8 inches right here. So if we take our 2 steps, and then 2/3, 2 2/3 steps, that'll get us to our ladybug. Now, let's say that we have a positive outlook on life. We are always walking this way. We're always walking forward. Our destination is to the right, and walking to the left is a negative step. So, what we want to do is we want to take our 4 inches, our data value, and minus our mean, which is where we're standing at, minus 36, and divide by our standard deviation, which is how much one step will take us, 12 inches. This will give you 32 divided by 12, which should give you, the 2 2/3, what we found out before. But that's like our fancy way of calculating. This is what I was talking about up here. If that makes it easier for you, this is basically what a z-score is. Stat majors might get really mad at me because I'm oversimplifying it and I'm not even necessarily representing what it is. But that essentially is the process that we're using to find the z-score. Now we'll hop into examples. Hold on. Oh, there we go. Okay, so this is saying what percentage of the area under the normal curve. So that means that the distribution is according to the empirical rule. It's standard. Under the normal curve is to the right of the following z-score. So we have our curve, and we have our z-score, which is 2.90. We'll say like that's right there. Well, it'd be like right here. Yeah. Sorry, blue screen there. We want to find what's to the right. It's giving us our z-score, so we want to use our norm.s.distribution one for this because we have our z-score. Now, if you recall, when we use norm.s.distribution, it's calculating to the left. But since it's giving us a percentage, well, it's giving us a decimal point, which will turn into a percentage. Since it's giving us that, we can just minus that by 1 or 100, depending on whether you convert it early. Because this is 100%. If it's giving you this percent, we can take the 100 and minus this percent to give us this percent. So I'll show that in Excel. 290, 2.9. So equals norm.s.dist, and then 2.90, and then comma, and then true, and then close parentheses, and then we'll take that 1 minus a, oh, I forgot the equal sign, 1 minus a1, that gives us this. So our percentage is 0.187, 0.187%. That is our percent of this area. This one is telling us that the rainfall in a town last year measured 79 inches. If the annual rainfall has a mean of 53.37 inches and a standard deviation of 10.97 inches, how many standard deviations away from the mean was the rainfall last year? And we want to round our answer to the 2 decimal places. So it's giving us all the information we need to calculate the z-score. How many standard deviations away from the mean? We know that a z-score is how many standard deviations away from the mean it is. So if we take our equation, we know that our data point is 79, and we know our mean is 53.37, and we have our standard deviation. So z is equal to 79 minus 53.37 divided by 10.97, which should give you 2.336 dot dot dot. It goes on some more. But since we're rounding to the nearest 2, it'll be 2.34. I do want to know, when you plug this into your calculator, you want to compute that. You want to treat this as though it is, as though there are parentheses around this. You want to do this first, and then you'll divide that answer by 10.97. Now we want to calculate the standard score of the given x value. So it's basically laying this out for us. I'll set it up, but I don't want to solve it. So z is equal to our data point, which is 67.7, minus 58.7, divided by 6.7. And then you would solve for that. This one is the same idea, except for this time we have our z-score, so negative 2.72 is equal to our data point, which is 33.40, minus our average, divided by 2.64. And you would solve for this. So you times that by that to get rid of this, and then you would minus this from this, and then divide by -1. This one is a little bit trickier. We have two different things that we need to calculate, two different z-scores. We have our water bottling facility, and we have our cola bottling facility. And we want to compare. So we'll take the mean of the water bottle. We'll find the z-score for both. So water z-score is equal to 37.4 minus 35.2 divided by 2.04. And then for the cola z-score, we would take 28.8 minus up from 26.9 and divide by 1.51. And then whoever has the biggest score would be the winner. Now, I do want to say that if it's scored like 0.13 and like 0.12, Hawks is going to say that they're pretty much the same. Yeah. This question, which is using the maximum z-score that a data point could have in order to remain in the bottom 30. So we're going to use our norm.s.inv and plug in 0.30%. Well, we don't need the percent in that case. And you don't need a true for that one. Okay, last question. Last year, the revenue for medical equipment companies had a mean of $50 million. I'd like to write down what we have. Mean of 50 million, standard deviation of 12 million, and our data value is equal to 79. So we need to find the z-score first, and then we need to put that in to find the percentage with less than 79. So 79, it'll be less than. Which is what it calculates. So you would do 79 minus 50 divided by 12, and then whatever you got for that, you would do the norm.s.dist, and then true. Okay, I know I've been speaking fast. I'm just trying to shoot through these because I know that it's a lot and I don't want to make these videos too long, but I do feel like it's important to work through examples. If you have any questions, please let me know and I will answer them as soon as possible.